Alright, so back with another video. Here we go. Hello and welcome to the live stream. What I'd like to do now is take a look at the next question on LeetCode. Largest BST subtree is the question. So we'll see how that goes. Let's get right into it. Given the root of a binary tree, find the largest subtree, which is also a binary search tree, where the largest means subtree has the largest number of nodes. Largest means the subtree has the largest number of nodes. A binary search tree is a tree in which all the nodes follow the below mentioned properties. The left subtree values are less than the value of their parent root node's value. The right subtree values are greater than the value of their parent root node's value. Subtree must include all of its descendants. Can you figure out ways? Excuse me. Can you figure out ways to solve it in with linear time complexity? So, yes, I think I know what to do. Basically, what we're going to do is we're going to determine at each node, we're going to find two properties. Is this a root of a binary search tree? And a sum of how many nodes in that subtree. So the sum, we can actually do both of these properties at the same time. The sum is going to be the number of nodes in the left subtree and the number of nodes in the right subtree plus 1, right? That's for the root. And is the left subtree a binary search tree? Is the right subtree a binary search tree? And if that's true, is the left root less than the head node and the right root less than the head node? Actually, to check if it's a binary search tree, you have to be a little more involved in that. Typically, the way I do it is I use a recursive. The last few times I've done it, a recursive algorithm that says you have a minimum and a maximum, and you're going to check on the left subtree with a certain minimum and a maximum, and on the right subtree with a certain minimum and a maximum, and that'll tell you whether or not those are valid binary search trees with regard to those minimums and maximums in order for this head node to be a binary search tree. So, yeah. So pretty interesting. And basically what we're going to look to do is we're going to basically do find all of those properties in one shot. This is kind of just like checking for each node, determine if that node is a binary search tree, which is effectively just, is this tree a binary search tree? You can find out for every node in the tree in the same amount of time it takes to figure out if the tree is a binary search tree. And similarly, you can count the number of nodes in the tree and the number of nodes in any particular subtree. All of those things are sort of all this. You can do this all the same way. So yeah, this should be relatively easy to do. I'm about to eat those words if I say that. Let me be careful. But I think we can sort this out. Excuse me, we can figure this one out. So we're gonna have recursion. We're gonna have int ret equals 0 initially, and this recurse will say it returns a Boolean. And also, it could be a pair. I mean, you could even return a pair. Thinking, yeah, you could do a pair. Why not? So why not do a pair? Use the utility library, and we want Boolean and integer for our return values. Our recursion is going to be. Almost did that wrong. And we want certain things. So there's an int, which is min, or I don't like min and max because those are keywords to functions. We could do just a and b, or lesser greater, just a, b, something like that. It's fine. And we have tree node root. We have a, b, tree node root, and I think that's all you really need. I guess you can. No, that should be fine. That should be fine. So what we're going to do is, and then we just want auto f. So we can do this recursively. And basically we say, yeah, recurse on root. I want to say, and give it recurse again. Actually, there's a few things we need to do here. Let me say, or a few more parameters need to add. The return value is, we actually want ret at the end of it all, which is going to be a little confusing. But what we're going to do is recursion, this recursion is actually going to give us whether or not that node, particular node, is the root of a binary search tree, yet true or false. And it's going to give us the number of nodes in that binary search tree. And while we're calculating that, we're also going to update ret with the maximum returned values as we go. So, okay, let's say we have, so base case is if not root, then we want to return a pair that looks like the following. It's true and it's 0, right? So it's a binary search tree by it's vacuously true. That's a binary search tree, and there are no nodes in that binary search tree. And now we have f of, now we want to say the min is int min, and the max is int max. We haven't we don't have maximum values yet. So there's f of root left will give you something, and we want to modify the minimum and the maximum values accordingly. So if in order to be a binary search tree, the left subtree has to be a binary search tree such that all of the values on the left side of that tree are less than the root node. So root value, so we'll say int val equals root val. This is going to be, if the values on the left side need to be less than, and also less than a, less than, actually this is, it's a little confusing. They have to be less than a and less than the root node. And everything on the right side has got to be greater than a, has got to be greater than or equal to this value, the root value, and it's got to be greater than or equal to b, right? So we modify these minimums and maximums. And it's actually everything on the left side doesn't need to be larger than b. Or it doesn't need to be larger than value, it just needs to be larger than b. Needs to be smaller than val though. It needs to be, yeah, it needs to be smaller than, excuse me, I'm just thinking, I'm sorry. Yeah, needs to be smaller than, right, it needs to be smaller than the root, but it doesn't need to be larger than. It just, you can use the same b, it doesn't change for the left side. And the right side changes in a symmetric way. So it's that's just A, but now you want the maximum of val and B. I think there's another way to do this. So figuring out whether or not you are a binary search tree means all the nodes on the left side need to be, also you need to have, they have to be strictly less than, like if there are duplicate values, this gets really awkward, by the way. Yeah, so all the values in the left subtree need to be less than the root node. It doesn't say anything about the maximum though. And then on the right side, all the values in that subtree need to be greater than the root node as well. And so you continue passing these minimums and maximums from the previous instances or previous sort of layers above in the hierarchy. So that's how you kind of keep those, maintain those. So you have the left and the right, and now you want to say, let's say auto P1, auto P2. Actually, we do want the assignment operators to take sort of the right hand, where they call it the R value reference to the sort of move semantics, the R value reference, what that's sort of move into the P1. And so we get P1, P2, and we're going to say return standard make pair of, right? Did we write make pair? Yeah, we did. Yeah, it's underscore. It's going to be P1 dot first. These are the booleans, and P2 dot first. So if the left subtree is a, if the left subtree is a binary search tree and the right subtree is a binary search tree, and it's got to be these two, and there's one more piece, and the root node value is greater than or equal to A. It's got to be greater than A, and it's got to be less than B, right? In other words, and the root value is in the bounds that we were given already. Greater than the minimum and the maximum. I did that wrong, didn't I? Kind of got those confused. This is the upper bound and this is the lower bound. So the lower bound might get lowered by the root node on the left side. Doesn't say anything about the right bound. And the upper bound might get increased on the right side, but we don't say anything about the lower bound on the right side. A little confusing. So check if that, so this will tell us if we're a binary search tree or not. We also want something else, which is the number of nodes beneath. So int num nodes is going to be p1.second plus p2.second plus 1. And finally, we're going to say if check ret equals standard ret, a max of ret and num nodes. Yeah, something like this is what we want. Oh, can't see it. And how do we do? Does this work? Does it compile? And we use, I tend to forget that. 6, 3, wrong. Nice. Okay. 10, 5, 1, 8, 5, 7. And why are we wrong? Excuse me. Let's see. So left side, we say this minimum is A, and oh, that's why. I'm sorry. I thought these were, yeah. I thought these were not quite right. So the minimum value might get moved. You want to take the maximum of these two, and the largest value you can have might get smaller. Yeah, that's my mistake. We got one now. Okay. Interesting. Right. That's very interesting. So this becomes on the left side, the minimum value is 10. It's so confusing. No, on the left side, all the values need to be smaller than 10. So actually, it's the other way around. It's, I think I got these mixed up. It's the maximum, the upper bound on the left side is what gets modified. Now everything needs to be smaller, so you actually modify the upper bound on the left side. And it's going to be this, it's going to get potentially get closer, right, the upper bound. And then on the other side we say, and this is the maximum of val and A. Right, on the right side, everything needs to be greater than this value, so the minimum possibly increases. Yeah, that's what we're looking for. Something like that. It's a little confusing, but hopefully that makes sense. So we could try another use case, another test case. Hope that makes sense. Yeah, I think we can go for it. I want to try just one, like some couple, what do they call that? All right, let's go for it. Oh, kidding me, really? What is this? I should have tried a few more of these test cases. Man, I feel like it's been a while since I got a. We'll just do new. I feel like it's been a while since I got it exactly correct on the first shot. So I don't know. I don't take enough time to run through different test cases. But why would this be? Why would this not work? Like why would you get what? There's a left and there's a right. This would be true, would be 0, would be +1. Check. How do we get even if the left and the right are true and 0, right? 1, 2. How is this? How do we not get a 1 here? What happened? Oh, it's 2's on the left side. That's not a binary search tree. Oh, is that why? No, but the 2 should give you at least a 1. Like, how do you not even get a 1? I'm so confused. Oh. Oh, it's not a... Huh. Maybe I'm wrong with this. Because it's not a binary... That node itself is a binary search tree alone. However, oh, that's interesting. Oh, that's very interesting. Okay, so there's like check is, oh yeah, oh, very interesting. Okay. I think my algorithm might fail on more test cases, on like larger test cases. So if it's a BST, is this one. However, whether or not it's a binary search tree for the node above is this check, which, yeah, that's kind of interesting. Huh. What about these other test cases now? I kind of want to try a bunch of different things now. I don't know. I kind of want to just submit it too because there are a lot of different possibilities. I don't know. It would take me a while to go through all the possibilities. Let's go for it. See what we get. Should probably. Yeah, I was gonna say something should be wrong. I don't think it's right. I think there are issues here. I don't know. Actually, now I don't know how to do this and to do a better job here. I kind of just don't feel like going through all the cases. I mean, maybe I should have. No, you know, that's really interesting. The problem is, we are definitely wrong. Yeah, there's actually two properties here. We have, is the left subtree a binary search tree? Is the right subtree a binary search tree? Right, or just is this tree a binary search tree? However, we actually, our binary search tree check does only operate at the root node. It's a different check entirely on, if you eliminate each layer above. Oh, that's awkward. Okay. They'll both end up being binary search trees in order for the root node to be a binary search tree. However, you could have one of them be a binary search tree with different parameters rooted at that root node, we'll say. Oh, that's very interesting. Huh. Let me think about this now. Oh, this is a more interesting question than I thought. I screwed up. Got a habit of doing that where I think I have the solution. I just start going at it, when in truth I don't actually have the solution. A little too ahead of myself. You kind of want to do, I guess, 2 recursive checks, something like that, where at every node you want to check, is this a binary search tree? It's kind of challenging. I can check for one node, the root, if that's a binary search tree or not. I don't know if I can at the same time check that if all the other nodes are also binary search trees. The reason why you have a problem is because of the the dependency on the sort of the layers above. They kind of impose stuff where your node could be a binary search tree. However, the nodes could be too large, could go outside the bound that you have. You may want to know, is this a binary search? You may want to ask a different question. Or modify, like, excuse me, that feels good. You may want to modify what you're doing such that what you return, so you can have a query of each node, which is this the root of a binary search tree, and what's the largest value and what's the smallest value in the tree, right? Those 3 properties. And if you know those 3 properties, then the node above it, the parent node, if you know on the left subtree and the right subtree, you know whether or not it's a binary search tree and what the smallest value and the largest value are, what those values are. Now, if those values are bounded by the root node, then you could tell whether or not it's a binary search tree from the smallest values and the largest values, as well as whether or not those are binary search trees. So let's do it that way. Let's actually do 3 integers, and then there's a 4th integer, which is going to be whether or not they're a binary search tree, the largest value, the smallest value, and one more integer is going to be that's 3 integers, right? The largest value, the smallest value, and the number of nodes that you see there, right? We'll do it that way. So we can do better. So we can say, and yeah, we still only need this. I don't think we need to give these values anymore, right? Let's suppose for a moment we don't do that. So the largest value and the smallest value, we'll say the smallest value is int max and the largest value is int min. Basically, we don't bound anything, I guess, something like that. And they gave us a bound for the values, so that's kind of nice. So we can kind of use int min and int max freely, a little more freely. And let's say the last value is the number of nodes. And then we say, okay, we have int largest, int smallest, and also num nodes, right? And so we say, excuse me, we have the left side, and it's not a pair anymore, it's a tuple. Hopefully this makes sense. Hopefully this makes sense. So we'll just say R1, R2. Right? And we're going to say is BST is get 0 of R1 and get 0 of R2. I'm actually going to comment that out because I want to modify that. We're going to say int smallest, or smallest. I can actually put these over here. So the largest, can do it this way. Largest is going to be, so the smallest value is going to come first, the largest value is going to come second. So we'll do largest values are going to come second. Standard get 1 of R1, 2 of R2, and we're going to say the smallest is going to be the minimum of these values. These are the two smallest values from both. Two smallest values from both recursive calls, from both subtrees. And I want the largest value. It's going to be the next one. And actually, you can do min element because you're going to compare, you're going to use value here. You're going to include that guy. And you're also going to have max element. Also include value. And then you're going to say, well, actually, no, we don't do that yet. I'm sorry. Take that back. No. I did that wrong. I'm sorry. So, okay. So we get the minimum and the maximum from the two subtrees, the smallest of the left subtree, the two subtrees, and the largest of the two left subtrees. And then we also, we want to say is BST, we get if they're both binary search trees and the smallest of the left subtree, or the largest of the left subtree is less than the value, and the smallest of the right subtree. So you can do, I don't know if that's, we'll just do both BST. Both are BSTs, and then bool check is going to be both BST and these two things. Just thinking, I kind of want to put this in a way where it's kind of somewhat legible. So we have largest less than value and smallest greater than value. Or value, yeah. So the largest, see, that's the thing that's tricky. It's so confusing. So it's the, oh no. Let's back up here. We have so many different things to check. So we want to check bool both BST. Let's start with that. That's going to be get get 0 from R1 and get 0 from R2. All right, they're both BST. Now left largest is going to be an integer. the largest value of the left subtree is going to be get 1 from R1, and right smallest is going to be get the smallest value, excuse me, it's 2 is the largest. Smallest value, which is 1 from the right subtree. And then we're going to say bool check is both BST and the left largest, excuse me, is less than value, and the right smallest is greater than value. I realize that is really confusing. And that's our check. And now we want to say int num nodes is going to be get the fourth value of the left subtree plus the fourth value of the right subtree and add 1. Third value of the right subtree, left subtree, add 1. And now this tuple at the end here, we're going to have the check, 2 things in between, and the number of nodes at the end. And we're going to say if check, then ret equals standard maximum of ret and num nodes. All right. Realize that's quite involved. So yes, so the number of nodes always gets set no matter what. However, we only update our return value if we know this is a binary search tree, because both of the 2 other trees are binary search trees, and the largest value of the left subtree is less than this value, and the smallest value of the right subtree is greater than the value that you're looking at. And now we need to update the smallest and the largest values. So int smallest is now going to be int. Now this is going to be the standard. Now this is going to be what we were saying before. Now I thought there was going to be one more comparison somewhere in here. Yeah, that was why. Okay, yes, no, that's fine. So we'll have the min element of these 3 things, which is get the smallest element on the left subtree, get the smallest element on the right subtree, and then val, right? And that's going to be an initializer list with those things. And then we do the same thing on the other side, or for the largest. Max element is going to be this guy. Left subtree is largest, right subtree is largest, and the value, and you take smallest, largest, return those for this node. So we've got all this information that we're working with here. And yeah, we don't even need these anymore. Let's see what happens. Does it compile? The best question to ask here. We don't have the initializer list. Shouldn't this be? Doesn't this work? Can we do this? I guess it doesn't really work nicely inside of a Lambda function. Probably gets a little bit confused at what's going on. That's a standard algorithm, right? Huh. Two arguments, but one was provided. Interesting. Could just do max max, also works. that too. That also works. All right, sweet. Does it work on all the test cases though? Okay, it works on those. Does it work on everything? It does. Hey, look at that. Not bad. Yeah, 80%, 77%. Not too bad. I have kind of a lot going on here. What do I want to say here? Yeah, that's it. I mean, I should have done better than this, you know. I should have got it the first time. However, I kind of took it for granted. I thought it was a little bit easier than it actually is. So, not bad at all, but definitely could have done a better job. Yeah, I definitely could have done a better job. There's probably a faster way to do this too. Instead of returning these tuples, making these tuples every time and returning them, you can actually do something a little faster, which is like this kind of a thing. I like this, which is kind of neat. So int reference to like smallest, int reference to, let's do this. This is a fun thing to do. I think this will make it faster. I don't know how much faster, but faster. So instead of making a tuple, you can return a Boolean, and what you're going to do is you're going to set smallest equal to int max, and largest equal to int min, and then, oh, there's one more value, which is the num nodes. Num nodes, we'll call it. And what you're going to do, so these references are actually values that you're going to pass back. They're going to be effectively return values. You're going to modify them. So we'll have int smallest, largest, and num nodes. These basically they'll be like, I'll explain in a second how it works. So the return values are going to modify these integer, like sort of the, what do they call that? The where these are stored, where the data is stored, the memory, I guess, the memory locations. Yeah. So these are going to be references to these integers. So you're actually going to give access to the memory locations for where these integers are stored. That's where you're giving the smallest, largest num nodes, and you give it a reference. So when you do that, you can modify what's there, and basically outside, after calling the function, then these will be modified to the values you want. So you can do that recursively too, which is kind of neat. And I'll show you what that looks like. So we would say, there's int left smallest, left largest, and left num nodes. You can actually do L instead of left. In theory, this will use less memory. And then you can also do R smallest, R largest, and R nodes. And then you call L smallest here, L largest here, and L num nodes. Right, and the same thing over here. R num, yeah, R smallest, smallest. Okay. Right, and now we have both BST is, oh, these are Booleans now, by the way. Both BST is going to be R1, R2. Left largest is going to be, we don't need that to modify that anymore. We actually get it already. We have it. Check is going to be both BST and left largest less than value, right largest, right smallest. 1, 2, 3. R smallest gives us, right? And then we say num nodes is going to be left num nodes and right num nodes. Okay. And then now here's the tricky thing. When you return these values, you got to set these. So you got the smallest, largest, and num nodes. We're gonna say our new num nodes, something like that. Actually, not even. It's just this one. We're gonna change it here. So left num nodes plus right num nodes plus 1. If check is true, then we update to num nodes. This value is going to get returned when we're done with it, and this smallest is going to be the left smallest and the right smallest and the value, and then the largest is going to be the right largest, the left largest. Oh, I should probably keep it consistent or somewhat consistent. Two largest values and the value itself. And now we only need to return a Boolean. We only need to return, I think check is what we return, right? Something like this. And it should still work now, even though now we don't have any tuples that we're using. And it looks like it does work. Let's see what we get. There you go. Okay, is this faster? It might not be, it could be just the same. Yeah, okay, we got 8 milliseconds. We got 8 milliseconds before too, though. I don't know if this is much faster. I think it's better in terms of memory. Yeah, it's a little bit better. Slightly better, not really much better. Not that much big of a deal. Not that much of a difference. Pretty good though, overall. I think this is like a pretty acceptable solution. This might be something that's faster than this, but overall this is okay. I don't know if this is a little bit easier to code and understand than the tuple one is, because the tuple one you have all of these like getting the value out of the tuple. You sort of have this encoding in the tuple that kind of gives you. You could probably use a, what do they call that? What's that called? A D. I forgot the name of it, but I think it's structured dereferenced, structured binding, structured dereferencing, something like that. You could use that to figure out what the values are. I have no idea how you parse text files. I made like a vector and a vector to hold each section, and I looped like 3 times. It was super slow, so I gave up. What's up, Yuki? Welcome back. Hello. Are you still here? Because I realize not everybody hangs around if I don't say hello. I think it looks like you are. Forgive me if you feel like I'm invading your privacy now by checking, because I would hello. This is like impossible. Yeah, what's up? I have this habit of like I'll respond to your text after you type it, and then I'll realize like, oh, that was like an hour ago. He's probably not still here. So welcome back. Hope you're doing all right. Hope everything's going well. Really, no idea how you parse text files. I made like a vector and a vector to hold each section, and then I looped like 3 times. It was super slow, so I gave up. This is impossible. Yeah, what do you do with your text files? Let's see what we can do here. Let me see if I can. Let me see. Hi. Howdy. Let's see. We'll take a quick, because we finished this problem, so we could take a moment to finagle with text files. Hold on. Let me see if I can. Let's see. Here. Oh, it's pastebin. Okay. Nice. It's probably like the easiest thing ever. Is it? Maybe. I don't know. Pastebin. Let me go to pastebin. Let me see. Pastebin. Oh, you can't see me. Oh, yeah, we can't. I do that pretty regularly. I have the wrong. All right. Pastebin. And then we want to go to the one that you gave me, which is this one. If I do, can I do it this way? There we go. Okay, users, some account. All right. So we want to parse this guy. Okay. So what we're gonna do when I mess around with text files, I like to use Python. Now I don't know what programming language you're using. Feel free to let me know. Can I do? Oh, that was why I did this, because I don't want to do anything regrettable. Okay, this should be fine. So we'll just go to the desktop. We'll go to stuff, right? Stuff, I think, is the one I have on my desktop. There we go. All right. So we're gonna open up a shell here. Well, yeah, we're gonna do it. Are you ready for this? And we're gonna vim some text, a txt, and we're gonna paste our text, and we're gonna save that. So vim is, so if we cat that, we'll see our text file, right? We can actually less that. So vim is like, so I don't know if you're familiar with like Mac or Linux, but these are all like Linux programs that I'm using, less and vim, and it's basically vim is like a text editor for Linux. So I basically just created this file now, and cat will print it. Right, and we can do that so we can see it. So we can scroll up and yeah. So what we want to do is parse it, right? Now I can only do it with 100 else if statements, CPP gaming. Okay, so you want to do C++ and you're going to do games. Okay. I used Windows Ubuntu subsystem like once. You did, okay. Yeah, because what I want to do is, like I said, when I parse text files, I like to use Python. So I was going to use, where is it? I was going to write a Python script to parse this. However, if you want to parse it in C++, all right, so it gets a little more involved. And the reason why it gets more involved is you're probably going to need to use a C++ compiler for Windows, which the only real one you can use typically is like MSVC. There are other things you can use. I think Bloodshed is a compiler for C++. Bloodshed, let me see. It's a real pain in the neck actually developing on Windows for C++. I really don't like it. I should get this. Like I don't know why I don't have this. So the thing that's really confusing about IDEs, so this is an IDE. The thing that's super confusing about IDEs and compilers, a compiler, so it's a lot easier to understand from like a Linux perspective. A compiler is what actually takes your code and converts it to a program, which is a really abstract thing to begin with. But in Linux, it's really simple. You can just go, I don't know if I have it on my computer here. Do I have G++? Help? No, I don't have G++. Do I have GCC maybe? I don't think I do. I don't have GCC either. But basically, you would just go like GCC compile me, compile me as like an argument, and then you hit enter, and then you get another file, which is like in Windows, you have like executables that you could just double click and they run. You get a file that you can just kind of type like dot, compile me, and then it usually be like I forget actually what the extension would be. I don't know if there would be some extension, and you think it's an A. I don't remember what the default one is. It doesn't even need to have an extension, and then you can run the program. And it just runs. Like it's like super like easy to understand. Whereas with with Microsoft, you basically have your choice. You have to have you have an IDE that accesses the compiler, and then you compile it through the compiler through the IDE. Same thing with Java too on Windows. Like it's really confusing on Windows because it's very hard. You basically in Linux, the code and the IDE that you edit the code in is separate from the compiler, which actually compiles the code. Whereas on Windows, usually you basically almost can't use the compiler without the IDE. So that's really confusing. That was something that was ridiculously confusing for me when I was attending university. I was like, how do I do anything? Because I don't get it. Because those things were just like smashed together, and I was like, why does Windows do this stuff? Like, why do they do these things? It just makes it so much harder to understand what's happening. But yeah, so this is an IDE. This isn't necessarily a compiler though. Like you may be able to get the IDE, but you don't necessarily have the ability. GCC based compilers, right? So what you would do to use Bloodshed and to use the compiler is there's this thing called mingw and this other thing called cygwin, which actually emulates Windows. It does a similar thing. That's actually what this is. I'm pretty sure this is mingw, what I've got going on here. Oh, whoops, I didn't mean to do that. This basically takes Linux binaries and allows you to run them on Windows. And so you can use the GCC and G++ compiler, which is a Linux, it's a free and open source C++ compiler. You can use that to compile your binaries for Windows. So you don't even need to go anywhere near the Windows Visual Studio or the other things. And that's confusing too, because you're like, well, what the heck is mingw and cygwin? Like, what is it? Because I remember when I was reading this stuff when I was at university, I was like, I have no idea what's going on. Like, I'm reading this and I'm like, I just want to program stuff. Like, how do I just program things? So yeah, that's like probably one of the first hurdles you run into. Like, I literally never resolved this problem in all of my years at university. I was there for like 6 years. Never figured out like what was the problem with this. I think because I had very few C++ classes, and I focused so much on the code, I didn't really focus too much on like how do you actually compile a program? How do you actually, like, the really simple things? And I didn't really have very much help either. You know, there wasn't really. I mean, this is many years ago now. This is, I want to say, almost 10 years ago. So, you know, there's stuff on YouTube, but there wasn't. I didn't even know to use YouTube to look up stuff for programming tutorials and whatnot. But yeah, so sorry, I realize I'm like off on a tangent, but this like brings back a lot of memories. A.out, is that related to this? Yeah, A.out. Oh, okay, I see. So, yeah, I'm sorry. The reason it's related is I need to open a compiler. I need to access a compiler to actually. I need to access a compiler in order to actually write the program to parse the text file. And the reason why I need to do that is because the text file actually has to be on a system. Like, I could go, there is one of these guys over here. If you do this is an online compiler that I can write code here, but the problem is that if I wanted to access a file, I'd have to upload a file here. And can I do that? Maybe I can. I don't know if I can. Enter your note. No, I have to upload a file for this to actually parse that file, because there's file opening libraries, I guess, you got to use. So that's why I'm getting into all this, is because it's I don't want to open up Visual Studio. It's gonna make my stream, I guess, crash. I don't know. So let me see. Hold on. Let me see. I guess I'll just open up Visual Studio. I mean, that's okay. I don't have G++. I think I do have it on this machine somewhere, but like I have to go find it where I installed G++. I kind of want to get Bloodshed now. Now that I'm thinking about it, it's like I kind of want this. I kind of want this because I don't like using. Like, this is it. This is what I want. Like, I don't like using Visual Studio, and they even have Visual Studio Code, which is similarly lightweight, but I don't like that either. It's kind of awkward to use. So yeah, Bloodshed's pretty cool, I guess. I should look into using this. I want to, yeah, I'll think about that. Because if I'm gonna be doing stuff like this in the future, where like people ask like, hey, how can I do this in C++? I would like to be able to just be like, oh yeah, here you go, you know. But now I got to go through all the aggravation of doing the following, which is opening up Visual Studio. And Visual Studio is so annoying. There's so many things I don't like about Visual Studio. Let me show you. Like, there's so many things that bother me about Visual Studio. Let me try opening it. So like the first thing is they have a license. Like, why do you need a license to write code? Like, who does that? You know, like it's like having a license to write things on paper. You know, it's like, what kind of a maniac? Sorry, I don't mean to. Sorry, that's too far. I'll just say I don't like that you have the licenses for Visual Studio. It's like really obnoxious. Somewhere I have it on my yeah, somewhere I have Visual Studio installed. You can debug let's see. But Visual Studio has so many cool tools. You can debug external processes if you inject DLLs with 2 buttons. Yeah, kind of. I mean, I shouldn't say kind of. I mean, there are things about Visual Studio that are good. I don't mean to be like too negative. You know, I do like Visual Studio. It's just I don't like that much. I don't like it that much. Quick feedback. Let us know what we're doing. No, not now. There's a lot of things about it that are just annoying to me. All right, let's open a new project. Let's start that. So project solution, not open. No, we don't want to do that. Let's do a new one. Okay, new project. Put this in stuff on my desktop. So we're just gonna call it. Oh wait, yeah, no, that's the right one. And project one, we're gonna say parsing. Okay, did that. Yeah. There's a lot of things I don't like about Visual Studio. A lot of things. I kind of don't want to go into too much detail. I'll just say that there's a lot of things I don't like. That should be new item. We want a class. No. Yeah. Excuse me. Oh, I should name it. I'm supposed to name it. There are things I do like too. Don't get me wrong, but there's a lot of things I don't. The things I don't like kind of outweigh the things I do. So we want parsing. We're just a parsing CPP, right? And we're gonna do. We need a main, right? Oh no. Sorry. And we want input output, right? IO stream. And let's just quickly test our program here. Hello. Just to see that this will work. Do I need to have an input? I don't think I need to have a. Okay. So it just closes immediately. So we're gonna also add. Keep our window open. So this is it's gonna wait for a character. It's usually how I. Yeah, there we go. Hello. All right. It's kind of usually how I debug or how I tend to run the programs. Okay. So what we want to do. You're not wrong though. It's super laggy for no reason, even in my small console projects. Yeah. It's like it's just so heavy. That's the thing. It's really heavy, and it's kind of disorienting too. Like I said, like the decoupling between a compiler and the IDE or the extreme coupling between the two is very disorienting for like a newer programmer. And then also, like if you wanted to move your program, like just plain old like compiling older programs is a pain in the neck. Like if you wanted to use, a newer version of Visual Studio to compile something that was compiled with like an older Visual Studio from like 10 years ago, the older Visual Studio from 10 years ago uses a different compiler, so you actually have to update your compiler. So you have issues where you need to get a different IDE to work on the code base in order just to compile it, which is really confusing because it's like, well, the compiler's outdated. Why couldn't you use the same IDE and all the features and all the good stuff, and then just tell it to use a different compiler when you compile? Something like that. Like it gets kind of crazy. And there are like compatibility, like I've run into compatibility issues like that where the code base I was working on is like from 10 years ago and I couldn't use the newer Microsoft Visual Studio to actually work on it. So I had to go get an older version of it and hope that it would work. Like there's all kinds of weird stuff that would come up. I can't even remember exactly what would come up, but it had issues with compatibility in that regard. I remember running into that and I really didn't like it. But anyway, so okay, so we want to parse this file. All right, so where's our file for starters? Our file we put in desktop stuff. Where is? Here it is. Okay, so somewhere here, it's like this. This is the path, I think, right? And we're gonna say include a string. Const file path. All right, give ourselves a file path name, or give ourselves a file path. It'll be a string. Oh, whoops. I think I think I had the insert button turned on. Where is that? Yeah, I don't want to insert things. All right, we'll save, periodically save. I like to do that. All right, so there's a file path. Now we want to open the file, which I tend not to remember offhand. Now here's another thing that's weird about Windows. You need these double what do they call that, backslashes. So now the opening files, I tend to have to look this one up. I don't do it very often. I do it in Python often enough where I would remember it offhand. But let's see, there's just an open, I think. F open, is that what you do? Yeah, I think it's F open is what we want. So give me a moment here. I think IOStream contains this. Use an example. File pointer, F open. Is that what you do? Why does that feel wrong? I think I never open files in C++. I want to say I practically never do it. So bear with me. Bear with me. As this is a C, yeah, because this is a C library. I was gonna say, I don't think that's right. Now we're looking for opening in C++. Yeah, this is what we want. C++ input output, right? Open. Just do open. It's fine. And then what do you do with it though? Fstream is what you want to use. Okay. So we're going to do a file stream. All right. Got it. All right. File stream. And create file is open, clear. We want to read from our file. So we just do fstream open, and once we've opened the file, we want to do things with it. Yeah, get line, get, here we go. Yeah, that's what we want to do. So we want to read our whole, where is this? What am I doing here? Binary input. I don't want to read it as binary input. I want to read it as like just text. Read back from the file. I mean, you could do this. That's kind of interesting. Yeah. How about, is there another way to do this? Get line. I like that. Yeah, you can get line, read some, blocks of characters, read. What does read do? Let's do this. Let's go with that one. There's a few things you can do. There are like a few things you can do. Raw read. So this actually will read this into, let's reinterpret cast as character string. This gives you like just a string of, This is an integer. Bin 1, 2, 3, 4. Raw bin, hex, show base. 1, 2, 3, 4. Yeah. I have stream text is tell G, construct string to stream size is seek G, is read size. Read the string. 0, where is that? Pair file for next snippet, read entire file into string. If this works, then tell G string read into string. Okay, I mean we could do that. let's read our whole size. Tell G tells you the size. Okay, let's do this. Let's do it that way. It's kind of neat. It's not very quick, but it's definitely neat. We're looking for. Oh, this creates an. Oh, interesting. This will actually write to this file. That's kind of neat too. So. Just looking for something. I forgot what it was I'm looking for. You're going to hear this very obnoxious noise now. C1s are faster? Yeah, I bet they are. Standard if stream, file path, string line, while, file line. Yeah, that works too. You can do it that way too. I think you... That's another approach. What does tell G do? That's what I wanted to find. Yeah, tell G. Turns the input position card indicator. Oh, interesting. Okay. So if you... So that starts off at the end, I guess. Current position of the get pointer on success, -1 on failure. So I want to say that once you turn 6, is there some routine that it's called? No, this is okay. Well, we could try that. I want to give that a shot. I want to try this piece of code. I like what you just did too. Yeah, I was thinking about that. Like you could do a while read also, something like that, or yeah, you can use the this operator, the greater than operator. Let me see. Let me try this on if string stream. So we'll say standard if stream, or not? Yeah, an if stream of input in file. We'll just say, or just istream, and we want to say file path. Oh, please. Okay, file path, and we don't really care about the other parameters right now, right? There's other parameters that mean other things that I don't really pay attention to. iOS binary 8. I'm not sure what these do. iOS stream binary 8. What is? Gotta look at the constructor for. Gotta look at the constructor for the if stream to know what that does. So it's going to be the open mode. Okay. And it's a binary thing. So open in binary mode, open for reading, open for writing, and it's just iOS base in, we'll say, implementation defined, opens a file and configures it as the associated character sequence. You can, you can also just do this, just open, give you a file buffer. That works too. And then parameters, call the constructor on open. Just thinking, oh, it's called through the F stream anyway. Okay. Also 8, what is that? ATE, I don't know what that means. 8. Seek to the end of stream immediately after open. Ah, that's what we want. Why we want 8. Oh, that's what I was wondering. I was like, so we're gonna do binary and 8. We're gonna OR those two. Interesting. That's exactly what they did. All right, that's why we want those. I want to give this a shot. See what this looks like. It's the first time doing it this way. Oops. Didn't mean to do that. I meant to keep these two. Well, it's what it's standard iOS base, right? iOS base 8 or standard iOS base, and the other one is binary, right? So we can do this. And that gives us this open mode. And now we say, and the way they did it before is if this works, then you can say is parenthesized initializer. Really? Oh, it must be in much older versions of C++. That's right in the... Yeah, because this is a really old compile. This is really old. This is from 2017. It's from a while ago. It's from 4 years ago. This was new then too. This is the newer version. Let me see. So I guess they must have changed that since then. Oh, you can use an initializer. Okay, try that. Does that even exist in this older? Yeah, it does. Okay, neat. All right. Let's give that a shot. Let's see how we do. So well, this could be, that doesn't really matter. And we want to say, okay, so int size or auto size is equal to, we said tell g, right? Is tell g. And then we want to say standard string contents. We're going to say, we can actually just say the size is what we want, right? Size. How did they do it? So, oh, right. And we're going to fill it with a null characters, right? So it's not filled with garbage when we start it. And then we want to put the contents in. So we want to read into this contents is seek g0. Okay, right. So now we seek to the beginning, and then now we say if is read contents at the beginning of this. I want to read the size. Is that right? Yeah. And then if it works out, then we're going to print it, which is going to be the contents. Okay. So this will just print it out, right? See if this works. Oh, stuff is not the right. Some text is what we want, right? Okay. I don't know if you're still here through all this, Yuki. Hopefully you're still hanging around. But there we go. All right. So now we got our text into the program. Okay, sweet. So the parsing that you want to do. What was the parsing that you wanted to do? Exactly. Because now we have a string with the contents, and we can actually even put it in here, and we can say like now we can call like a subroutine that's like void parse const standard string s, and for now we're gonna do nothing, but we can call parse on contents. Oops. And excuse me. You can change your version to 20, I think. Yeah, boom. This is the got him. The struct I'm filling out. Stream ID 64 is the 765611198, etc. Okay. Oh yeah. So what? Yeah. So what is this? And what I wanted to say is, what was I saying? I don't know if you can see the link. It looks like it may have been automatically removed. The link. What was I saying? So timestamp, most recent users. What was I saying? What was it doing? There was a comment I wanted to make. Okay, I can't see your link. You might be able to split the link into two pieces, into two different messages. Like that might work. Stream ID 64. 64-bit. Okay. There's something. What was I gonna say? So this is a JSON. It looks like something similar to a JSON type of a file. So, oh, the paste bin. Okay, it'll show that. Let me see. Oh, is your? Can we not see? It looks like there's a message underneath. Oh, there we go. VDF format. It's values format. Okay, VDF. Yeah, I was gonna say. So with parsing files, there's usually there's a definition for the format for the file that you're parsing. So you said VDF. That's probably something online we could look up. Oh, let me do that. Virginia Defense Force. Oh, there's a lot of VDF wiki format. Disambiguation VDF file. Is it? It sounds like it's something for like a class. No. Okay. Okay, so it's values. It's got. I guess it's a custom format. So that's something you'll find like on the job. I guess is that you'll find like different kinds of formats for different files. There's all kinds of different stuff that, and often programmers and companies and whatnot will even create their own files and file types in different formats. That sort of stream VDF. If you want to Google it, stream. Oh, Steam VDF. Okay, gotcha. Let's see, Steam VDF. Let's see. Oh, config file. Okay. What is this? Opening config.vdf file. Oh, it's a Steam's config file. So that's a custom. Yeah, that's like basically a proprietary, not a proprietary format, but I guess it might be proprietary. I don't know. But what I wanted to say is right. So it looks like it's Steam's file format. Yeah. So okay. So what you can do is you kind of need the definition for the format, but it looks like for what we're working with, you have actually. Yeah. Let me just look at it again. You have. It looks a lot like JSON, but it's not quite JSON. So you have so. File formats and parsing file formats is actually like not a trivial thing. It depends on what it is. In this instance, because you have what's called nesting, you probably want to create a stack when you're processing your file. Basically, the users is sort of the outer section, and then you have a sort of a stack on the inside. So you see the beginning. You start a new, I guess, stack, sort of new recursive call, something like that, and then you process what's inside until you see the closing bracket. And so you sort of have you basically want to take everything that's between these two brackets, and the stack. I guess the stack would be what you would use to figure out what's going to go between these two brackets. So you sort of have like what the users are going to be, and then you're going to keep parsing until you get to this other bracket, and then that closes everything off for those users. And then as you work through here, you happen to know that the file format looks like a number line and then another opening and closing bracket with some stuff in between. So there'd be sort of like another stack, or rather another element on the stack. And then so you would process this sort of in its own piece. And then once you find this closing bracket, you can kind of relate it back to this piece, and then relate that back to this opening piece, and then it looks like you just keep iterating again and again for all of these opening closing brackets. Inside of these, it looks pretty simple. It looks like you just have basically two sort of white space characters, white space. So you would remove all the white space, read this, remove the white space, read that. And it looks like on the left side, the first thing you see is some kind of like tag, like a name of something, some kind of a label, and then a value. So you have like tag value pairs, it looks like. So then you have some value that comes after it. And yeah, so you can extract the label, extract the tag. And so like, I guess you kind of got to figure out like, what do you want to do with parsing the file? Like for me, I probably would want to create like a hash map something like that. So I'd have probably, you could have a vector for this users, and I guess all the users would get shoved into the first, I guess the first element of that vector would be this whole thing pushed back. And then inside of that element would be, I guess, another vector of these things. And these things, this data structure would probably be, it looks like there's a number associated with this. You could create a struct, right? I think you were talking about structs before. You can actually just create a struct object where this is sort of like, you know, the user ID. I don't even know what you would call it. Like the I want to hit the stop button here, but I want to leave this up. So you could literally create a vector. You can have a user struct. You have a vector of user structs, and then the users, or I'm sorry, I'm not sure exactly how you would want to do this. I guess you could make each of these a user struct, and then this is then the final thing that you're done parsing it pushes it all into a vector of user structs. The only thing about that is that you probably want to key, like you probably want the like user info here, and you probably want like a hash map of, I mean, you can do whatever you want, right? Like basically what I'm saying is that now once you know the format that the file is supposed to be in, then you could figure out what kind of a data structure do you want to put the data into, because that's going to be how you access your data. So you got to have like some ideas about how you'd want to do that. I think for something like this, like it's simple enough to just use like literally hash maps of hash maps. So like one hash map would be like the users, would be the key, and then everything inside here would go inside it would be hashed to that, and then that inside of that hash map. The reason why it's a little complicated in C++ is because each like section of the hash map you have like different types involved. That's kind of one of the reasons why Python is really good for parsing files, because it's duck typed, meaning every part is like just automatically the program underneath figures out what the sort of object types would be for all these pieces. Would be just kind of actually like just a simple Python dictionary would kind of handle all of this pretty nicely. You don't really have that kind of a data structure in C++ though. You have more like hash maps of hash maps, sort of nested hash maps. So start them using, I don't know if it's wrong. This looks okay. I mean, this looks like a plausible thing that they might be using. So let me see. Let me think about how would we do this. Yeah, we want to read line by line, create kind of a stack. I think figuring out the data structure you want at the end is probably better. So like, I think it's perfectly fine to just take all of this information and basically move this into its own part of the struct, which is like the user ID, basically. We'll call it user ID. And these could all just be strings. I mean, it's fine to leave these as strings, because when you want to parse it later, you can kind of figure out. And I guess you would even have, you would have a hash map of strings. I think that's better, because that way these could be whatever you want them to be. So, oh no, I'm sorry. Actually in that case, you don't even need a user struct. You could just say a hash map of strings to values, and then we'll just add a string in here, which is just going to be the user ID. And then you can create a vector of those hash maps, and then call that vector like the user's vector, and then push back each one of these as you go. Like that's a simple way to do this. That's maybe not the best way because it's not really object oriented, but it does get your data into a data structure that you can work with. So let me show you what that might look like. So let me put this into a thing here. All right. So now we have our contents, and now we want to parse. So we want to parse our contents, and we want to return, we're going to just auto ret, let's say, and then we're going to just debug. Do we not have auto in this? Oh, yeah, we'll come back to that. So this is going to be, we set a vector, which we're going to want, oh, nice. Excuse me, and we want, try not to say too much. That's, when I say hash map, I mean an unordered map. So let's say vector. Let's call it type. We'll use a type def. Users vector. Vector of, and we want to use strings. So we're going to return a users vector, and hopefully this makes sense. For now, we're going to just do this. What's wrong with this? Unexpected expected identifier, class template vector. Why doesn't that work? Unordered map, string to string. Am I missing something? I'll explain, let's use ints if we do this. I want to say it's got to go the other way around, the type def. Okay, yeah, that's why. You can see I don't use type defs too often. I use them from time to time. All right, so, okay. There we go, great. So users vector, nice. Okay. So we want to debug our, just want to for auto x in ret. We'll say, you know what we can do? Can I do it this way? You know what we'll do? We'll put this right in here. Yeah. Auto ret. Okay, that should be better. Now, for each of these, we want to say for auto pair in the map in x, and we're going to say new user. Do it this way. And then we're going to say yeah, we'll just print everything. That's fine. That's okay. So this is going to show us that we parsed it correctly, right? Once we're done. Okay. Backwards users vectors at the end with type def? Yeah, thank you. Yeah, thank you. So first, second, so we're going to say new user, print a new line, and then we're going to print all the data that we have. And then we're going to do that for each of these. Basically, it's going to be each part of the vector. Now, when we parse, we're going to get our vector out. Okay, so what we want to do is we are going to use a stack, and we're going to say, use characters, that should be fine. Character stack, we're going to say parens. And we want to say, now you see why I have that habit of writing all of my includes at the top. It doesn't really matter that much because you'll be reminded by the compiler, but if you're not using, you're reminded by the IDE, but if you're not using something like Visual Studio, then it's good practice. So what we want to do is we can read lines from our string. Get line, I think we can do that. String get line, I think that's built in. Let's find out. Let's see here. I think so. Yeah. Standard get line. We can also do s.getLine. Excuse me. So let me see. Find empty substring contains replace append. Somewhere in here we gotta have a get line. Where is it? Where is it? Operations. I want to say. I'm not seeing it. Oh, get line. Yeah, that's the one. Okay. Yeah. All right. So actually, this comes from the. We can do an iStream. We kind of want. We can create a string stream, I guess. We could do it that way too. I want to say. Well, we want to process the string each new line character. We kind of want to go line by line. That's sort of what I'm looking for. Can we create an iStream from a string? Can you do that? iString stream, yeah. That's kind of what I want to do. Oops. Kind of what I want to do. Extracts formatted data. Let's do get line. Yeah. So let's create an iString stream and then use get line on it. Let's do it that way. There's like a lot of ways you could do this. So we'll say ISS. String or S stream. Right, string streams. ISS is going to be iString, yeah, iString stream of S and incomplete types not allowed. Can we do that? Where is the constructor? Can I? How come we can't do this? Basic iString stream. Does it need to be a basic iString stream? What? Why doesn't this work? Whoops, what is that? What did I just open? Oh, it's a browser. Can I not do this? S stream. Oh, that's probably why. Okay. There we go. Okay, I was gonna say. I was like, why? How come? I don't know how to do this otherwise. So while get line. So we'll say. I don't know. You could do const string s equals get line. Can you do this? Not s, but we'll call it line. Get line of ISS. Does this work? Does this make sense? I don't know. I don't know if I could do this. Could try it. Learning, man. I hardly ever do parsing in C++, so it's just new to me. In buff. We do have get line here though. It's from basic stream. I mean, Yeah, input.getLine, right? We do .getLine, A for, does getLine need to have stream size, count? Really? Size of character string pointed to by S. Oh, okay. Oh, I see. Interesting. Forgive me if this is getting a little bit, I don't want to say boring, but taking some time. So we'll do that. String, line, just going to have the same size as S, and we'll say ISS.getLine of S is that size. Do new line character. Okay. No matched argument list. Really? So does that not work either? I mean, I want to go, you could use this operator, the greater than, but the problem with that is, or can you even just do getLine? I mean, I don't know. Straight from, not even the stream, but just the basic iStream. Well, yeah, that's, It's formatted data. It's not quite. Huh. Let me see here. Oh, you don't need the delimiter. Character type pointer. You don't really have. Where's A? What is this? It's a character array. That's interesting. Well, you could do that, I guess. Could do a vector of characters. Does that make sense? It's a good one, a pointer though. Can you do that? This doesn't seem right to me though, you know? This doesn't seem right. Also, oh, you know why? Also, that's wrong because, I'm sorry. It's also wrong because this is line. However, what if you did that? Okay. Oh, that makes a lot more sense. Okay, that's kind of what I was going for. I was like, why? Something doesn't seem right here. All right, now we can say if, so just say if line equals users, then continue. Right, we skip the users portion. We're gonna ignore that. We know that's what we want. Say if line equals opening parentheses, and we want to strip all the white space as well. So we're gonna say, so we can actually, we can get line once and not even bother here. We can even get line. The opening braces and the closing braces, we would say, what do I want to do for those? We don't really need them. I mean, they're kind of not that important. So the first opening braces, I mean, not that we don't need them, but the first opening braces really denote the beginning of, I guess we want to do something like, we can kind of throw that out too, is sort of what I'm saying. Yeah, we can kind of throw those out. Basically, at each level, like each brace has different meaning, and we kind of want to imbue each brace with different meaning. That's kind of what I'm saying, but it doesn't really matter, right? The opening and closing braces are kind of irrelevant. We really only care about the values in between. So we probably want to think about it a little bit. Yeah, opening braces. So if we say, so we'll do users. We'll just say users, or entered block, something like that, or entered user block. Say initially false, and then say if opening and entered user block, then we're going to say entered user block equals true, and we're going to parens that pushback. I'm not entirely sure how I want to do this, by the way. I'm kind of just thinking about this as we go. And then we'll say something like if line is this guy. So there's a few, yeah, I guess there's a few things to think about. Oops. Yeah, like I said, parsing is kind of a non-trivial thing, because it really depends on the format of the thing that you're parsing. So it's kind of an interesting problem, parsing. And also, I hope you're still with me, Cordy. Hope you're still with me. All right, because I've had to parse files in the past as per employment. Like, it's actually a pretty significant skill, pretty important thing. Comes up quite a bit. It's a non-trivial thing. You can't really automate it too easily. Like, you can automate it, but you can't automate the writing of a parser, if that makes sense. Okay, so here, if you've not entered a user block, then we're going to enter user block to true. In any case, we're going to add this parentheses, else if entered user block and not entered, we'll call it user block, and then we have the other one, which is or users, yeah, call it a data block, I guess. I'll do it this way. All right. And haven't entered a data block. So we have, if you haven't entered the user block, set that to true and exit the else if. If you have entered a user block but you haven't entered a data block, then we're going to say entered data block. It's true. And now, actually, so the reason I want to make this distinction is there could be something that's not, and I'll explain in a second. Yeah, I'll explain in a second. And then else. So this is data. And now we want to say, okay, so basically parens dot pop, and we'll say if entered data block, then we're going to toggle that. Or sort of exiting it. If we have if enter data block, else if entered user block. So yeah. We actually don't need there's like a few things here. So if you have like a lot of nesting, things get a little more complicated than this. You probably want a different kind of a parser. However, we only have two nested things that are kind of not really that nested, so this doesn't get too bad. So we can kind of, I'm watching. Oh, you're still here. Okay, great, awesome. So it's not too bad. Like, we don't really need to go crazy with the with handling the nesting, but the nesting you probably would end up doing something with using the stack. You do more with the stack if you have nested stuff. But in this case, you don't really have much nesting, so we can kind of just use these items here, these two booleans, basically to tell us where we are. So, but otherwise you probably would use like a mapping of like the level of nesting. You'd use another map that would tell you what level you're at, and that would kind of guide you, I guess, something like that. Yeah, I'm not actually entirely sure. I'd have to think about like what exactly what it would look like. There are programs that do heavy nesting though. Like if you're familiar at all with Elasticsearch, this database uses really heavy, very heavy nesting. Let me see if I can find. I just want to see if we can get a picture of how much they've got for the data that comes out of Elasticsearch. What it looks like. I can't find it. Whatever. We'll just leave it. Whoa. We'll leave it for now. Yeah. So we're not gonna basically, like, yeah, they have really heavy nesting. You know, if you can imagine this file that we have, but with like, you know, something that would look like this, where it would have, you know, another group inside, and then another group inside there, and then another group inside there, and then have more, you know, things in between, right? That would be heavy layers of nesting. There are things like that have that you would parse. That would be like JSON. You probably would just use a JSON parser. By the way, you could actually, for this, you almost could use a JSON parser. It's not quite JSON, but it's very close. You could probably modify a JSON parser to handle this, but for now we're gonna write our own custom one. So, okay, entered user block, and we throw out the first line. We really could throw out the opening and closing parentheses. Like we really don't need to do it. Well, the reason I want to do it this way and keep the opening parentheses is because the data at the top, it's outside of parentheses, so it kind of tells us what the next sort of parentheses, what the ID is for the next parentheses. So anyway, so entered user block. If we haven't entered a user block yet, which is going to be sort of everything, then we set that to true. Otherwise, we can say if we are in a user block, then we've entered, and we haven't entered a data block yet. Now we're inside of a data block. And in any case, we're going to push this parentheses onto our stack. This is exiting our stack, and we would say if we're in a data block, then we're no longer in the data block. If we're now, there's a tricky thing here. If it's going to be not entered user block, or not entered. If we're not in a user block, so we just left our user block, and we're in a data block. Oh, excuse me. Oh, I see I'm sorry. I'm confusing the data block with the user block. You should probably call it users block. If we're right, so we would expect, right, if we're in a data block, then that means we just exit the data block. That's a what do you call that? That's nested closer than the user block. And then otherwise, if we're not in a data block, that means we're exiting the user block. So then we set the user block to false, and then pop. And finally, we would say this is data itself. So process data. If we're not in a user block, so there's a couple things here. If we've entered the user block but not entered the data block, and basically we want to know that the line isn't empty, and not line.empty, right? Skip that white space. then this is, which by the way, we actually want to, in each case, we want to strip the white space also. Strip white space from the line. So we can probably write our own routine to strip the white space. I mean, there's a few ways to do this, but the simplest way would be probably like the following. I think I want to say there's a routine built in already for stripping white space. That's another thing about C++ and Python. Like Python has a strip white space built in already. C++ doesn't. So let's find that. Let's see, is space. We want to say that's remove if, remove. We can do a remove if, actually. That's kind of neat. Use algorithm. I don't know if we have algorithm for the C++. Hopefully we do. We could try that. What does this do? Unary predicate is basically is space is what we want to use. So we want to remove if and use is space. CC type. Can we do that? Let's do void inline strip white space. Oops. Standard string S. We're going to say remove if s.begin, s.end, and the predicate is going to be is space. Does that work? It looks like it might. String S line. Okay, so we'll strip white space first. Now, once we've done that, we want to say, what does the line look like? I don't know how efficient this is too, by the way. I feel as though this is not as efficient as it could be. But it kind of doesn't matter for our parsing purposes. So if the line's not empty, if you entered a user block and it's not the data block yet, then we want to say our, oh, here's another thing. So we want to say, we'll say, all right, yeah. So once we enter the user block, we're going to take our users vector ret, and we're going to say ret.push back a new, basically a new item. So it's just going to be an unordered map, an empty unordered map. Okay, this is an interesting thing here. So enter a data block if you process data. And if you entered a user block, if you haven't entered a data block, and the line's not empty, then we're going to take ret.back and insert a pair, or you don't even need to, you can do it this way. And we're going to say username, user ID is going to be this line. Else, if you have entered the user block and entered the data block and the line's not empty, try to get all the cases. Then in the back, you're going to take, now you want to parse the line into two pieces, which it's kind of a mistake if we strip the white space from the line. If we use this remove if, that was kind of a mistake, because now we can't parse the line into two pieces. That's funny. So we don't want to strip the white space just yet. We want to strip surrounding white space. Outer white space, we'll call it. that consists of, you could do something like this, like you could do it this way if you want. You can say int front back. Front is 0. Back is s.size. And we're gonna modify this. Also, this should be a reference. And size -1. And we're just gonna do a for loop. Front is less than size, or yeah, plus front. And front and standard is space of s of front. So if this is a space, we're going to keep incrementing the front. Same thing we're going to do from the back. Oh, it's actually, yeah, it starts off at 0. This should be fine. Yeah, and then back is greater than or equal to 0. Same thing. Back, minus back. And now we want to s equals s.substring of, we're going to, the size and the count. So it's going to be from the front, and the count is going to be back minus front plus 1. It's going to be the back and front inclusive, right? The number of characters there. So that should strip the outer white space. Little custom routine to do that. And yeah, we inline this. I don't know if I really need to inline it. I think we won't inline it, I think. So stripping outer white space is really what we want. Hopefully that works correctly, because we want to maintain the white space for this routine. So here we want to break it into 2 pieces. So we would say, excuse me, we could do the same kind of parsing again, or a similar kind of a parsing that we did here, where we just take front, and then front is 0, line.size is space of line, increment the front, and then we want to say, oh, you know what? No. We already stripped the outer. Oh, yeah. We want to say it's not white space. So front is 0, or we'll just say X. Call it X. So this will figure out. Basically, this will figure out how big the first string is. So standard string. Called the left part line dot substring of 0 to x. It should be x plus 1, I think, actually. No, it's x. Yeah, x goes off to the end until it's a space, and then the right side is going to be line dot substring of x to, I guess it's going to be line dot size minus left dot size plus 1, something like this. And the number of characters. I don't think I need to add 1 at that point, because this is counting the number of characters. And so this is really to the end of the line, really. And it's going to be right. And then you just want to say strip white space of this. We'll do it in 2 pieces. Obviously, there's a few different ways you can do this, but we're going to do it in just like a really straightforward, not straightforward, but like kind of a, oh, we're gonna just kind of code it up this way. It's not really a generalized way, but there's a few ways you could sort of parse this into 2 pieces. And now you're going to say the left is going to be set to the right in the mapping. And now what you want to do, so that's if you're inside the data block, and when you want to exit your data block, dword, dw size, 256 character S buffer, static cast alloc, size character. Do you know why you have to do this? To allocate an array on the stack without a constant value. Allocate an array on the stack without a constant value. Dword size character buffer static cast character allocate dw size of character. Allocate an array on the stack without a constant value. Array on the stack without a constant value. Oh, that is, that's kind of interesting. I don't know what that is. That looks like static cast character pointer allocate size of character, dw size. Is that that allocate there, that underscore part? So there's in C and C++ you have malloc and another one. Malloc and free, right? This C is really malloc. So this, if you want to, so this doesn't actually allocate memory to the stack. This allocates memory to the heap, which is a little bit different. It kind of looks like what you were looking at. And if you want to allocate to, you would do new for CPV, or allocate. I actually don't know what you do for. Where is it? No, not what I'm looking for. A new expression. What you would do in C++ is you really would, usually, well, it depends on what you want to do exactly. You would basically, you have an array of memory that you can use. You can allocate a section of memory, and so you would do like a new of maybe some byte array, and bytes usually are characters, so you'd usually do like a character array, and that would give you like a chunk of memory. So it's kind of like, you see this placement new, something like that. Like there's, yeah. Basically, if you want to allocate memory, it's not to the stack that you're allocating your memory to, by the way, it's the heap. There's a difference between the heap and the stack. I'm not sure exactly what the code that you had there does. Oh, I have all these things open, close all these. You can close bloodshed too, we don't really need all this open. I think I have your format here already. Do you know why I have to do this? Allocate an array on the stack without a constant value. Alloc A is like malloc A, but on the stack. It's like a life hack. You can make an array with a parameter from a function. Huh. That's the size. Alloc A. What is that? So it does create on the stack. Okay, I was gonna say, so yeah, the malloc and it's malloc A. I haven't seen that before. That's the wrong one. Whoa. Yeah. Okay. Ah, it's Microsoft. That's what I was gonna say. I was like, this looks like a Microsoft. So this is specific to the, yeah. Well, I guess if you're making games, you'd be working with the Windows operating system on the stack. Yeah, yeah. Security enhancements. Yeah. Allocates memory on the stack. So they call it the stack, but I don't think it's. I think it's a misnomer. excuse me, usually you normally call it the heap, not the stack. And the heap, what it means is, so the difference between the heap and the stack is if you call a function. So let's say I call some function. We'll call it, I don't know. We could use lambda functions to give you some idea of like what's going on. And we're just going to say return hello, right? And that's it. We'll just say, so we have like foo. Now, if you call foo, it's going to return a string. If we have something on the stack, if we have this like an integer x equals 10, right? If you call foo and then you call some other function, we'll call, I don't know, who, right? Some other function, which actually we can make it available. Right? Wait, what's wrong with it? Oh, yeah. So if you call foo, which calls who, this x, this is on the call stack for foo, right? Foo will then call this, and inside here, this variable is gone, basically. It's technically in scope, however, it's no longer on the call stack. There's sort of a whole bunch of variables that'll be on the call stack when you call who. But when you return from who, now you still have access to C in this closure, and it's still on this call stack, and so you could actually print X even though you called who. So that's usually what the call stack or the stack is typically referring to. I think that's also really confusing. There's a call stack and there's a heap. So the stack usually refers to the call stack. However, sometimes they refer to the heap also as the stack. So the stack and the call stack. The heap or the stack, which you're looking at, is basically if you wanted to create some object. So we'll just say like struct thing, and we say int x y, and then you want to say okay, give me a thing pointer to some new thing. Thing pointer T is a new thing, right? What this is going to do is T is now allocated on the heap. I call it the heap. I don't call it the stack. Windows calls it the stack, but I call it the heap. What that means is that's actually in random access memory. That's like a piece of memory was allocated for this object, and now this pointer is pointing to where that object is stored. So if you can call foo and who all day long, but wherever this is pointing, that data doesn't change. When you return from foo, x equals 10 is gone. It's allocated on the call stack, but when the stack is popped, it disappears. That's that notion of a call stack. You'll probably hear me every now and then when I'm talking about algorithms. I'm like, oh yeah, this is on a stack, and this is still technically linear time or linear space because of the call stack. So that's what that's referring to, the call stack here. And the heap would be allocating memory to the heap. So that's why you're probably seeing in like help online tutorials and all of that, this alloc A is basically calling Windows version of something like this, which you don't necessarily need to use Windows version of that. You can just use new for C++. I don't actually know. Game development's a little bit different. Maybe they do use they take advantage of Windows internal processing somehow. I guess it's like something better to do, to use malloc A or alloc A. So that's what's going on there. You don't actually need to do that in a lot of cases. So if you notice, like I hardly ever use new in a lot of the code that I write, because the way that I write it, I kind of keep everything self-contained for the most part. So you really don't need to. And actually these containers, the vectors and the unordered maps and all that kind of abstracts a lot of that for you. You don't really need to, what do you call it? You don't actually need to call a lot of those functions to allocate memory. It'll kind of allocate it on the stack for you for these objects, which is really nice, really neat. makes life a lot easier. It's a lot easier to kind of understand and work with if you just kind of understand them as like sort of their own independent objects that are sort of automatically allocated and deallocated from the heap. So anyway, so that's hopefully that answers your question. Alloc A is on Linux too. Interesting. It's like a life hack. You can make an array with a parameter from a function as the size, at least I think. I learned this ages ago. So I'm probably a little wrong, but I know it's on the stack. WAI looks like malloc A is stack too. I'm lost. Oh, alloc A is on the call stack frame. It'll get freed when it leaves the scope. Oh, is that true? Alloc A is on Linux too. Oh, that's weird. You don't really need to use it then. That's super strange. I'm sorry. Maybe I'm wrong. Maybe I'm crazy. Maybe I'm wrong. I don't know. Wow. I don't know. I haven't used alloc A. Maybe it is supposed to be the call stack. Maybe I'm crazy. Really? Maybe I'm learning something new. Not considered good practice. Automatically freed. Oh, you're right. Okay. Look at that. Yeah, you don't really need to use this then. Actually, if that's really what it is, you could literally just create an array of characters, and that should give you the same thing. Machine and compiler dependent. Its use can improve efficiency compared to the use of malloc +3. Am I crazy? Am I going nuts? I don't know. Maybe I'm, because malloc is definitely supposed to be dynamic memory, right? That's the heap. Oh, I guess it's, I don't know. That's super confusing. I don't know. Maybe you're right. Maybe it's just on the stack then, not in the. It's allocated within the stack frame. Okay. But you don't really need to use this in the stack then. Huh. Its use is discouraged. Well, there you go. Yeah, that's new to me. I don't know why anyone would use it. I don't know. I've never seen that before. I take it back then. I take back what I was saying. I was wrong. Yeah, I don't know. Okay, here we go. I was wrong about that. I said Microsoft calls it the stack, but I have heard it a professor told me that once. That was a long time ago. That like, oh yeah, sometimes some people call it the stack because there's actually a pointer in the heap for like where the heap is. But never mind. I guess it's not. I guess I don't know. I don't know what he. I'm pretty sure he had said that. I could be wrong about that. I don't know. Now I'm like backpedaling on that too because I'm like, wait a minute. I don't want to be like making things up here. Yeah, the stack and the heap. Oh man. Allocates memory on the stack rather than the heap, as in the case of malloc. Return solves a problem for you. Why is this discouraged? Can be used, not required. Oh. Maybe I'm crazy. Wait a minute. Am I nuts? It allocates it on the stack, but it doesn't, it should free it off the stack then. Like it should be, Not abusing it. It's fine. I don't know why you wouldn't just, like every time you create an object, like it's automatically on the stack anyway. I don't really understand. I don't know, maybe if you need like arbitrary data or something. I don't know why you would use it at all. I don't know. Maybe I'm crazy. I don't know. I'm missing something. So there's really no problem with it that you wouldn't also have with declaring large arrays. That's, yeah. It's a bit silly. Large local arrays cause exactly the same problem, are not nearly as vilified. Recursion could just as easily pull the stack. Minus wanting you to hopefully counter the prevailing idea that the reason given in the man page is justified. Point is that the okay, yeah, okay, this is what I was saying. I'm like, well, what's going on here? I'm so confused. Exactly as bad as those other things. Local arrays, recursive functions, considered kosher. Not by highly experienced programmers, but I do think many people who fear LK do not have the same fear of local arrays recursion. Many people will shout down LK, will praise recursion because it looks elegant. Sean's advice, LK is fine for small allocations, but I agree with the mindset that frames is uniquely evil among the three. They are equally dangerous. Okay, there we go. All right, anyway. Brother. Okay. All right. It's confusing. Glad we went over that. Okay. Let's see. I don't know why it's there for anything but array stuff like that. I only use it for arrays. Yeah, like if you have the array, if the size of an array passed in as a parameter, C++ doesn't let you do character array DW size. There's some reason why. DW size would have to be constant expression type thing if allocated and exist. Yeah, exactly. Yeah. Well, you're right. Although your array, you can use a vector, right? Like just standard vector events. I want to say that's what you can do. This, although you're right. No, that's actually true. That's a fair point. Yeah, no, you're right. If you want a dynamically sized array, it has to be a constant expression. You're right. No, you're right about that. I forgot. I mean, you can make it any size you want, though. You know. Oh, that's interesting. What did they say then? Oh, fair point. Fair point. Hold on. Let me see. What were they just talking about then? And how do you even do that in C++ then? I have to go back to this post. What? Large local array. Yeah, hold on a second. I know you can do this. Yeah, you're right. You're right. Huh. I guess that's why you would use allocate. Yeah, no kidding. I didn't even know you could do that. I would usually use a vector if I had to. I would put it on the heap. No kidding. That's definitely something you'd want to use in games because it's a lot faster to not allocate things on the heap, instead allocate things in local memory. That's a good call. I didn't even think about that, man. Oh man, I didn't know that. I didn't even know you could do that. Wow. Yeah, that's really nice. I like that. I like that. So now you can use programmatically sized arrays inside the local stack rather than the heap. You do have to be careful though because you can. Excuse me. Ah, you do really want to use that then. Wow. Well, today I learned something. Thank you for asking about that, because I didn't even know. I didn't even know that, you know? It's not even aware. So anyway, this is so confusing, my head hurts. I'm sorry. Yeah, I was wrong about some things. I was wrong about, yeah, no, you were right about alloc A allocates to the local stack, which is literally the stack, and malloc will allocate to the heap, which is not local. So wait, so did you say are you a software? I'm confused, because it seems like you know a bunch of stuff about C++. I learned this ages ago. Did you take a computer science course? Is that why? Or are you a software developer in secret? Because I've got this impression like you know a thing or two about software, but also I'm not certain, you know. I don't know how to code it all. I just learn a little in my free time. I don't know how to code it all. Oh, okay, gotcha. Okay, all right. So let me try to explain. I'm sorry. You said your head hurts. So hopefully I can explain this then. I just learn it at my home when I'm bored. Understood. Okay. Because that's the impression I got. But I was like, wait, but how does he know about the stack frame and whatnot? All right. So right, as I said, so there's two pieces of memory, the heap and the stack. The call stack is what I was just describing. When you call a function, there's like a whole bunch of data associated with that function, and then you call another function that gets pushed onto the stack, all that stuff. And then when you call this new function, you get another stack frame, it's called. And then you call another function, you get another stack frame, and you get like a stack of, it's almost like, stacks are like plates, sort of each plate would be sort of a frame of just a bunch of information on each plate, you can imagine. Although that's maybe not the best analogy, because all your food would be squished if it was plates of food. But the idea is that once you're done with your function, you sort of remove one of the plates in the stack, and then you can go back to what you had on the other frame, and that allows you to basically call functions within functions, and then come back to whatever state you had once you return from the other function. That's this call stack. Hopefully that makes sense. The heap, on the other hand, is basically like just a chunk of memory sort of outside of your call stack, where you can reference stuff inside that memory. So you can like put some object into that memory and get a reference to it, and then later on in your program, wherever you want, you can, if you have access to that pointer, to that memory address, you can get that object back. So that's the heap. So you'll see there's some functions that allow you to put stuff on the heap and remove it from the heap, and then there's some functions that allow you to put stuff on the stack and remove it from the stack. And actually normal programming will create variables on the stack. What we just bumped into is something that's very similar to, so since the call stack has its own sort of memory section as well, you can actually do something like treat it as if it were the heap, and create an object on that you have a reference to now, and then you can destroy it later. Or it actually will automatically, once the stack frame is removed or destroyed and done with, however you want to call it, it'll just automatically get freed up. And as you said, that's pretty useful in some cases, because you might want to be able to make like an arbitrarily large, you might want to, you might have some variable that's like it changes each time your program is running, and so you don't know necessarily what it is. It's not necessarily constant, and you want to make an array of that size each time. Then yeah, you could use, and you want to put it on the call stack. You don't want to put it into the heap. Then you could use alloc A that we just saw, which also works for Windows and Linux. Although and that could be really useful for video games, because it's more efficient to put it on that smaller piece of memory than rather the larger heap. So that's probably whatever it was that you found that on, I guess whatever website, that probably related to games, probably why it was in there. So yeah, I learned something new, man. That's cool. Thank you for asking. To get back to the parsing that we were doing, by the way, we want to, we're almost done here, I think. So now we entered it, so processing the data, if we enter a user block, and we're not in a data block, then we know it's a user ID for that line, and we strip the outer white space. We don't need to strip any white space on that line. Now if we know we're in a user block and we're entering a data block, we're inside of a data block, then these lines we're going to break them into a left and right piece. So we'll have the left part and the right part, and then we're going to put that into the map in that way. And it's always going to be the last portion. And then we just need to, if we enter a new block, we push back a new empty map, basically. And then if we enter a new data block, we just set it to true. We don't actually need to do anything here in the data block. When we see a closing parentheses, if we're inside of a data block, we set the data block to false. And if we're not entered user block, if we have entered user block and not entered data block, then we actually, yeah, so here's the tricky thing. When we pop the data block, right? If we're in a data block, we actually want to add something. We want to add a new map to here before we start reading the next line, right? Because if you notice, data starts getting read before the next parentheses, but after this parentheses. So it's important that we just sort of always have something to write to on the back. And then if we enter, if it's a user block that we entered, and it's not, we're out of a data block, and it's the user block that we're exiting, then actually we're basically done with our algorithm at this point, and we should pretty much exit soon. And I think that's all we need. I don't know. We can run this a couple times to get an idea of what's going on. See if this compiles. Let's start with that. See if it compiles. Okay. Parse must return a value. Oh, I see. Yeah, I forgot. At the very end, we return ret. Let's see what happens. Oh. Oh, no kidding. It worked. Or no, wait. Oh. What? Oh. Let me just see. I don't think we printed anything. Check. Okay, so it compiled, but we didn't print anything in ret. I think this doesn't do what I think it does. So I think this, what does this do? Let me see. It's ISS iString stream. Let's see. What does this do? I'm looking for get line, right? It returns a reference to the string. Returns this. Input.getLine for a that's kind of confusing. Input get line true. What is this return? Eventually return false, right? Yeah, I mean, yeah. This should work, right? What I was doing should work. Let me just see. I thought it would work. Let me just see what happens. Whoops. See if this at least. Okay, it does. Oh, it did parse. Okay. So the parsing did work. I mean, yeah. Let's do this. This should basically... Ah, look at that. Me snap, okay. Oh, it got kind of messed up, the printing. And let's strip. Oh, I think I see the problem. Well, let's do this. Huh. That doesn't look right. Yeah, the white space is super awkward. What is going on over there? Also, I'm lowering my voice now. Let me turn up my voice a bit. Let me just turn up the gain so I can whisper. It's really loud though. Okay, yeah, so I can kind of keep my voice down. It's getting late over here. Yeah, I don't want to speak too loudly. So this is really strange. Well, no, this should be fine. Just thinking. What if we didn't strip the outer white space? Why does it look like that? That looks so strange. Let me just print one of these. Okay. When I did stuff, we'll get like new aligned at spaces. So persona A, name A, persona name 1. If it was line per line, line 0 would be persona and 1 would be name 1. And that's when I lost it and deleted everything. Oh no! No, don't get too upset. It's okay. It takes time and practice. Now this is really interesting. When I get line, this line. Oh no, wait. Huh. Can we just do this? By the way, I don't know if we do this, what happens? Nothing. I don't know how to make. I don't know, man. I think it's because the line is so large. It's got to be resized or something. That's super confusing. I don't know. We could try something else. I don't know. It's a tricky thing. Really don't need this, by the way. Yeah, this doesn't seem right at all. Something's wrong. I don't know what it is. Look at all this extra white space. I think that's because of all of the characters, the null characters. We could try something like this, I guess. Like, yeah, I don't really have a lot of experience with I don't really have a lot of experience with C++ parsing. Let's see what this does. Okay, that's a little bit better. Check. New user timestamp. Oh, look at that. Whoa. No kidding. Well, this isn't quite right. However, a little bit better. You putting your pointers and references on the far left side is a huge plus rep. Oh yeah? Thanks, although I'm not sure what you mean. Oh, do you mean over here? On the left side? I'm glad you like that. I'm glad you like that. Yeah, that's how I do it. So this is pretty interesting. Although I'm still trying to figure out where did this, when I parse, this thing here comes before check even. Like there's this opening parentheses out of nowhere. I don't know where that even comes from. It's super weird. I don't know. Like if we did this, we have hello. Hello. Right, it's closing parentheses in the right spot. Oh, I think I know why. Well, do I know why? Hold on. Why is this opening parentheses? Where does that even come from? It's got something to do with my parsing. However, I don't know where that's happening. I think it's that line. Oh, I understand. I'm sorry. That's my mistake. Yes. Oh, that's so confusing. Right, because we removed the users line. Oh, duh. I forgot. Okay, that makes sense now. Right, so let's just print every line then. Now here's the tricky thing, right? So we remove stripped users, opening parentheses, ID, opening parentheses. Right, now here's the part. We want to actually, we don't want these coming one after the other. Oh, okay, I get it now. We want it to be a full line here. So let me see. Just read and get line, get. Oh, you know what we can do? I have an idea. We can say, I know what to do. I know what to do. Alright, this is what we're gonna do. I know what to do. Let's go back. All the way back here. Okay. Yeah. Alright. I know what to do. We are gonna go ahead. We don't need toggle anymore either. Okay. Okay. What we're gonna do is we're gonna take this line and we're gonna say s dot in is it find first of, and it's going to be new line character. Yeah. There we go. And that's going to be the size of our line. Keep it real simple. Right? And it's going to be line.size each time. And first of this new line character, right? And this is the index, right? So what is it? This, just thinking for a second. 0, 1, 2, 3 character. 3 is the index. I really want to do a +1, I think. Oops. And then we're going to say, oh, what do we do? Okay. Get line. And now we're going to say resize, basically. New size. It's not S stuff, find first of, it's, can we do I? Oh no, that's why we can't do it this way. Shoot. Because the IS stream, right? Can we find first of in the IS stream? Can we do that? We don't have find. Oh no. Now this is a little bit awkward, isn't it? What does the internet say? There's C. Come on, there's got to be something for C++. like string n instead of string n or string n thing. Plus ref, plus ref. Thank you, thank you. Thank you, thank you. All right. Oh, use standard get line. Okay, that's better. All right. I was like kind of losing it a little bit. Yeah. You want to do it this way. Yeah, this is way better. All right. Thank goodness. So that would be a real pain in the neck otherwise. Yeah, this is so much easier than trying to like finagle things. All right, let's see what this looks like. Okay, that's a lot better. It basically prints the whole thing, and then check new user use ID, closing parentheses. Okay, we can do strip the outer white space. Let's see what this does. Check new user, timestamp, user ID, or password, account name, personal name, most recent, new user, user ID, timestamp, account name, remember password, personal name, some persona name. Oh yeah, persona, timestamp, most recent. It's printing in kind of a weird way, and then there's a new user at the end. So it's close. It's kind of getting parsed somewhat. What are we missing at the end? Oh yeah, we can just pop back. That's one thing that I missed there, one extra thing I didn't need to have. So check, new user, timestamp. So there's this extra character that gets written though. It's a little weird. I don't know what's going on there. And there's a few things to say about that. Suppose P first, P second. Let's do this. Let's just see what this does. Oh yeah, persona name, huh? Oh, because persona is not the same thing as person, it's a persona, I see. So, there is this extra, like, 6 in there. I don't know, how does that happen? I'm not the only one that sees that. It's really weird. It's very close to what we're looking for, though. We want... There's the one little problem here, which is... a small problem here. Oh, yeah, our substring, I think. I think this is wrong. We can also use get line, I think, to do this. It's probably better. Let me just see. I want to say this is probably the parsing here is probably wrong, this code. I assumed it's right, but it's, yeah, you see that extra 1 in there. I did not substring correctly. character or two. I don't know what happens if you do this. Name me. What? I'm a little confused. Oh, I think it's minus X, not left size. Hold on. I don't know. I don't know. Wait a second. No, it's not from X. No. This is wrong, right? Where? Whoa. Okay. No, that's fine. This will give you the white space. This really is to the end. It's fine if you get the white space. I mean, how? Wait a second. I knew this was going to be difficult, that last part at the end, the right part. Some account name 11. How do we get this extra 11 at the end? Why is it printing this extra stuff? What is that? What is that? Also the strip white space. I don't think that's right, actually. It doesn't seem correct. I don't think we necessarily need to strip the white space either. Somehow we seem to do this correctly, stripping the outer white space. I think that's right. However, stripping the white space in the first place doesn't seem particularly useful or correct. So we get rid of that. But I want to, we're going to do this. We're going to say string left is going to be line standard get line of line to left, or yeah, we'll do it this way. ISS2 of the line, and then left is going to be left, right, get line, and then we can use a delimiter, right? Yeah, there we go. That's what we want. We want to say first space, and then I guess to the end of what happens if we do this? I'm learning so much about parsing in C++. This is definitely fun, unusual. Okay. Account name, sub-account name 1, persona name. Remember password 1. Interesting. So this comes off super weird. What about, alright, so account name, sub-account name 1. left, get line right, left, right. What did we end up with here? Like, I don't even know what I'm looking at. Okay, let's see. Almost my bedtime here. Okay, test. This whole line with a space. Now, left, right, okay, interesting. Does this not do what I think it does? It's a little weird. Because there's this, I think there's this new line character. It's so strange. The left and the right, I don't know. I'm so confused. I don't know what. Oh, man. You could actually do this. Can you do this? How about that? What does that do? Oh, that's so much better. That is so much better. Oh boy, that's too funny. Okay, that's actually what we're looking for. Oh, that's so funny. Oh boy, wow, nice. Oh boy. Wow, that's so much cleaner. Okay. Here we go. We can rest assured our data is excuse me, stored in this missing one thing here. All right. So there you go. New user, timestamp, user ID, remember password, account name, personal name, most recent. There you go. So there's your data. It's stored properly in our map. Hopefully that works. I mean, hopefully that looks okay. We can remove some of this debug information. So that should parse your file. And now I kept the quotations and all the strings, but obviously you don't need to do that. You could actually strip all of the quotations. So does that, let's see. We could do like strip quotes. Hopefully that works. It's going to be from position 1. It's going to be 2 less characters. What is that? Those doesn't look like strip quotes. What do we get if we do this? Oh, it worked. Neat. We're going to do that for this part too. There you go. Alrighty. Hopefully, we're going to just make this, actually we can just make camel case, leave it as it is. Alright, there you go. So this is probably how I would do it for starters. Start with something like this, and I can add a bunch of other, you know, a few others here. Change, you know, some different numbers in there. And then I would save this as, override it. Give it a shot again. There you go. Get a whole bunch. You can change the data as you want, you know, as you wish. So what in C++, I made that one in C#, gets all the stuff from registry. Huh. Yeah, I guess this is one way of doing it in C++ here. So let me give this to you so you can do with it what you will. Let's go to paste bin. Now the thing about paste bin you gotta remember though is once I post this, paste bin has an expiration date, so you're gonna want to save it as soon as you can. Copy and paste it to your own file if you want to keep this, you know, if you want this. Did it work? Oh. Burn after read. So there you go. Hopefully you can click it. I want a rating. Let's see. I don't know if you can see the link. Oh, wait, look at it. It's the only thing I've ever made. Yeah, okay. Let's see. Let's see. Hopefully I don't get hacked here. Hopefully I don't get hacked. Going to iMager here. I'm scared, man. I'm scared. Uh-oh. Can I search imagers? I want a rating, sure. Let's see if we can do this. Okay, oh, it worked, okay. Oh, did I have it full screen this whole time? How long did I have it full screen for? Oh man, I have this like barely bad habit of full screening things. I don't even realize it. I want a rating, okay, you got it. Hopefully I just full screened it. I didn't mean to. Ayumi, Yuki, Huntex, alias. Oh, I did say Ayumi, library. Library Among Us, Counter-Strike, Final Fantasy, Gary's Mod. Wait, you wrote this? What do you mean? What? I'm confused. You want a rating? You full screen for like 5 seconds. It'll start and kill and disable buttons if a game is on. Oh. Yeah, and C# forms. Oh, that's kind of neat. Huh. Wow. So easy, just drag buttons onto a square. Nice. Nice. Yeah, there are a bunch of tools I'm not super familiar with for building GUIs. The one that I'm most familiar with is this one. I'm not even familiar with it, but this one is a thing that I've seen. GTK. It's for building UI, and it's a little complicated. It's a little complicated, somewhat. Drag and drop buttons in the square. So you got this, it does things. It'll start and kill and disable buttons if the game is on. Huh. That's kind of cool. Oh. So easy. Microsoft made it so easy. Yeah, that's right. It is Microsoft. Yeah, Google, Microsoft, C# Forms, Visual Studio. Oh, I see. I see. So you can start the game and then kill the game. Oh, that's fun. That's kind of crazy. I don't really know. I guess there's like a process ID that you save. So you can start it and then save the process ID and then you can kill it. And then I guess they generate all the events. Oh, I see. Wow. Pretty neat. Ooh, Untex. Yuki. Leet. Let's log in. And they have whole properties tab. Also, I hope you're okay with this being visible. Have a whole properties tab. What did I want to say? I forgot what I was trying to say. Yeah. Steam stores all that stuff in registry. Oh, interesting. I guess it's got a Steam API. Huh. Neat. Oh, I see. Oh, I see. You can access the registry to figure out what the game executable is. It's active process, right? Gotcha. Oh, interesting. Wow. That's kind of neat. That's kind of neat. Yeah, man, so there you go. That would be one approach to parsing it, and this was good practice because I don't do very much parsing in C++, so it's good. So getLine, so the two key ones are the getLine, the iString stream, the getLine, and the other is the greater than operator in order to sort of, yeah, work through each word, sort of word by word iteration. There's line by line iteration, then word by word iteration. That's like most of the iterating that you're going to need to do. Anyway. Wow, so that was fun. Yeah, we already solved this problem, so we're basically, it's gravy right now. We're just kind of hanging out. And yeah, file parsing is like a pretty significant thing. So, that took me a lot longer than I thought it would, but that was fun. I'm glad we did that. Just thinking about what else I want to say or do before I go. Well, I don't know. I guess I would chat with you some more there, Yuki. However, I want to go to bed. So I definitely appreciate you coming by and saying hello. It's nice. And yeah, it was nice little, what do they call that? Oh, I wanted to ask you something. You said something the other day. You said you're pregnant and you're gonna let another man raise the child if I don't treat you better. I guess first thing, I'm assuming you're a guy. I think I know who you are, but I'm not really certain. So I guess what I'd like to say is like, I hope you're not pregnant, unless you're married to someone, in which case that's fine. But yeah, I just wanted to ask because I was thinking about it and I was like, it's like, it's kind of a big deal. So, yeah. And the reason why I think I know who you are is that there's a certain someone who started hanging around my stream because of someone else that I was kind of like messing around with in a very public way. And this certain someone happens to be homosexual, as far as I could tell. and he's a pretty good-natured guy. He seems like he could be you. That's why I think it might be you. However, you could also be like a totally random person that has nothing to do with him or his group of friends. So I can't tell. I don't know. I don't really want to ask you directly either because it's like kind of awkward. Although I'm not sure if this is more awkward. I don't know. I don't know. I don't know. But yeah, I don't know. Anyway, I don't know where I'm going with all this. That just stuck in my mind. I was thinking about that, and I don't know. I don't know why I didn't bring it up. No, that was me. It was. Okay. No, I mean, I know it was you who said the pregnant thing. I mean, your memory's crazy. Yeah. From my Twitch stream, I think. Yeah, I remember. Yeah. It's not. Oh, I wanted to show you this. I don't know if I did when I wanted to show you this. Wait. Let me see if I can. My memory's not that good. It's a trick. It's a trick. And I want to show you the trick. You're gonna be annoyed when I show you this, but I wanted to show you it at some point. I may have already shown it to you, but if I haven't, so. Oh, give me 1 second. It's Discord. I gotta get Discord open to show you. And Discord's taking more than 5 seconds to open, so I guess we'll just sit back and wait. Okay, I'll just describe it. Oh man, dude, my red bar. I'll just describe it. So what was happening is Discord will show you in conversations other people's names. Are you ready for this? Yeah, this is gonna blow your cover. It's gonna be so annoying. So here you go. And I just wanted to tell you because I thought it was interesting. But yeah, because you think I have really good memory. So Discord Monka. Oh yeah. There you go. Yeah, that's what I'm saying. Is Discord, if you change your name, it'll change your name in like when the Discord updates. So or when you open Discord. So like I know so I saw you change your name, I think, and I was like, oh, I know who that is. Because so I'm assuming you're someone who knew me from my Twitch stream, and the person that knew me from my Twitch stream, there weren't really a lot of people coming to my stream at the time, and there weren't really a lot of interactions I was having with other people on Twitch. So I was like, oh, there's only like a few people this person could be. So I'm pretty sure I know who this is. And I told you that a few times, but I'm not sure if you caught it. And I was like, oh, like, I don't really know what to say other than like, I appreciate you coming by and saying hello. I'll say that. And it's nice. It's nice to spend some time with you. Yeah, but like, I don't know. I don't know how to like say that. It's like I don't want to blow your cover either, but yeah, I don't want to ask you directly either. Also, because like technically, these videos are public, even though there probably won't be that many people watching them. Just the nature of the videos. But yeah, I hope. Let's say I hope the person from whom you learned of me is doing well, and I hope she and her friends are doing well too. And I don't know. I've been trying. Obviously, I think you probably are aware of this. Like, I'm trying to forget about her as much as possible, for obvious reasons. So yeah, But obviously, you remind me of her, so it's one of the reasons why I like seeing you. Yeah. Aside from I appreciate you anyway, but there's that too. That kind of adds a lot, which I don't really want to admit, but like, Yeah, publicly say, then you go and delete my history. I don't mean to, yeah, I don't mean to be destroying your history, sorry. Sorry. Is that why you're so upset? You're like, oh, he said it, and then I can't show anybody that he knows. Is that? I don't know if that's why. I'm just guessing. I have no idea. I mean, I don't mean to make obnoxious assumptions or anything. So I explained why I deleted those videos though, right? I'm pretty sure I did. It's what do you call it? I want to do right by the people that made those problems. They made it like very clear that like we don't want, solutions out there for all these problems, because we want people to be able to, sort of have the joy of solving it for themselves. And it got to my conscience. I was like, yeah, like I'm a Christian. I'm supposed to like not be lying, and it's kind of like lying, it's not like, yeah, it's like technically lying, Oh, also I wanted to say, I appreciate that you watch my workout streams. That also makes me feel good. I thought about that too. I was like, yeah, that's the other reason he goes to my streams, is because I'm freaking naked and I happen to be muscular. Christianity rules. Awesome. I'm glad you like Christianity. Yeah, Christianity's good. Christianity's good. I found a church. And I've been doing that. And yeah, no, because I started working out again. And I was like, should I live stream this? I was like, we're gonna get freaking Yuki watching me, which is fine. Like, it is what it is. But like, I don't know. For some reason, I feel like if I'm working out on Twitch, like the way Twitch is set up, like it's kind of hard to find you. So like, or it's hard for people to find me. So like, I don't think I'll get that many people watching me when I'm exercising. However, if I do it on YouTube, like, that might get some attention, like a lot more attention than I realize. And like, I'm like afraid, because I don't want to have like all these videos out there of me exercising. Although I think I did have a few at one point, but like they were relatively tame. I don't know. I remember I was like flexing under the light and all that when I was doing the Twitch videos. So I'm like, maybe I don't want to be doing that. I wanted to say about Christianity to I'm like flipping between topics here, but yeah, no, I've been going to a church, and it means a lot. Like, really, I'm glad. And obviously, like, there's a lot of exercising as a flex. Yeah, it kind of is. Yeah, it kind of is. I was doing it at the time because I needed to exercise, and I just like interacting with people, and like I had a live stream. Like, it wasn't like a huge live stream, but it was big enough where people would come by and say hello, and like I appreciated that. I think I've said it a few times though on when I was doing that stuff, is that like it's actually kind of depressing, because like there's so few people that come to watch that kind of stuff, that actually makes you feel like you're just talking to yourself, because like you want to talk to the camera, because it's like, well, if someone's watching, you want to be engaging. But it actually just gets kind of depressing. Like, it just kind of, and also at the time I was going through some stuff where I was like, yeah, like all I could do is like really think about these other things, and it was really, really bad. It's actually like really bad. But I wanted to say something about Christianity, which is, just as an aside, something funny about exercising. Like, literally probably the only reason I do it. I mean, I do want to stay healthy, but like the extreme that I go to is like literally so I'm more attractive to women. But it's funny because like that isn't that valuable. Like it's just aesthetic. I don't know, something about it. It's like funny to me. But like that's like anyway. I don't know. I don't want to go with that. But no, what I want to say about Christianity is there's like a lot of pain in the world, and I've noticed a lot of it seems to come from like broken families and fatherlessness. And a lot of the reasons for fatherlessness, and like we're talking like people get really messed up when their dad's not around. I mean, I hear stories about, or I found stories. It's not really I've heard it, but I found stories on the internet about people where, it was maybe a boy or a girl, and the father wasn't around for the kid, and what happened is somebody came and took advantage of the kid in a way that was like horrible, and it really messed the kid's head up after that. And the kid ended up in like basically in prostitution, or in like, drug dealing, or ended up like becoming a gang member, or some variation of these things. Basically, kids that were left to defend themselves against the world. They were kind of like, a lot of evil was done unto them, and then they became kind of evil themselves. And one of the big reasons for fatherlessness is basically like sin, but not just sin, like sexual immorality. Like a guy might be a guy who, is in and out of prison, and as soon as he gets out of prison, he gets a woman pregnant, and then he goes right back to prison because he doesn't have a job or anything, he doesn't know what to do to make money. And then the kid from that woman ends up being fatherless because the father's, in jail. And I thought about it, and the more I think about it, it's like, that's probably one of the most damaging things on Earth. Like beyond nuclear bombs, beyond death and disease and plagues and stuff, and beyond, like, there are so many things that are terrible that happen to humans, but I'd say probably the worst thing overall is fatherlessness and sin, because it affects so many people so dramatically, and it actually creates more people who are like that. Like, it actually expands. Like, it doesn't, like an atom bomb goes off and it's terrible, but like, that's it. Like, you can kind of do something about it after that. But with fatherlessness, it's like you just have these tons of kids that become fatherless, evil is done to them, they become evil, and then they have a ton of kids and they can't take care of those kids, and then they're fatherless, and it just keeps going and going and going, and creates this really crazy thing. And right at the heart of it is, well, if we knew God, everyone knew God, they would have a much harder time doing those things. Now, obviously, the thing to remember is that a Christian's still a sinner. I mean, you can't be perfect. It's not possible. Only Christ was perfect. So anyone, even though sinners don't go to heaven, through Christ they do still. So even you might still have fatherlessness even amongst Christians, which is a tragedy. However, the church could be there to help the kids when they need help. They could maybe find a family, maybe fund something, maybe do something to help the kids out. Find a surrogate family, something. Take them in. But anyway, I'm kind of rambling on now. Basically, I've just been thinking about it a lot, and I thought of you also. That's what I'm telling you, is because I thought of you, and I don't want to get too deep here, but basically, a lot of the boys that were abused when they were younger, they became transgender women who worked the streets as prostitutes. They became homosexual men. They became gang members. They became, what are some other things? Actually, those are really the three big ones. And yeah, and usually, what is the stories I've seen? I'm not sure how many homosexuals I've seen. I've seen transgender men that were walking the streets and basically working as prostitutes. And like, it's brutal what happened to these kids, these boys. Like, horrible. I don't want to go into too much detail because it's really a lot. It's like, really, maybe another time I'll talk about how awful these stories are, but they're really, really sad. And yeah, I don't know. I thought of you, and I know that's like maybe not a very flattering thing, but it just reminded me of you. That's all. And I don't know. I mean, I'm not God. I don't know, but it's a sad thing. It's a hard thing, and yeah. And I guess one of the other things too is like, if you don't have a father, like for me right now, my dad died, he passed away. If you don't have a father, God the Father being your father now, or at least for me anyway, is extremely valuable to me. It's like, it's a big deal. It makes me feel like, maybe I'll suffer things now. I mean, I'm an adult now, so it's a little bit you know, I'm kind of in a different place, but being I don't know what I'm trying to say here. I'm thinking like, oh, okay, God the Father can like guide me, you know, like I won't be like fatherless. I won't be, you know, like without guidance, and I have the church. They can help me, and if I get stuck with things, I can go to the church. So yeah, so I appreciate you listening to all that too. By the way, I don't know how much of that you cared to hear, but or wanted to hear, how much of that you appreciated, but thank you for listening to that. So yeah, I'm gonna go. I'm gonna get going. I kind of rambled on a bit, and oh, I meant to full screen when I was talking, but yeah. Thank you for coming by, saying hello. I appreciate it, and hopefully that was, I guess, somewhat useful. How you might parse that in C++. Obviously, it'll be different in C#. I imagine you're probably trying to program that in C#. You're parsing. Yeah, you won't have the getLine function. You won't have the greater than operator. So you'll have to kind of probably use the equivalents in C#. But yeah. So yeah, thank you for watching, and thank you everybody else who watched, I guess, post-mortem or afterwards. And I'll talk to you soon. I'll be on tomorrow.